So quadratic functions, we have seen them now in this form, which we call vertex form. And it's y, or f of x, equals a times x minus h all squared plus k. Why do we call it vertex form? Because really we can read the vertex. So remember, if there's no h, there won't be any parentheses. That means it doesn't move left, right. If there's nothing here, that means it doesn't move up, down. Okay? Oftentimes, you will see a quadratic function in what we call standard form. And we did this last year. We talked about equations of lines in two different forms. We talked about slope-intercept form, where it looked like y equals mx plus b. And then we talked about standard form, where it looked like ax something x plus something b equals some number. Standard form looks like this. So there's not going to be any parentheses, okay? There's going to be a number at the end, but it doesn't mean that you move up, down, okay? It's just a different form, but often quadratic functions are expressed in this form. And just one other sort of piece of information. We call quadratic functions functions of degree 2. The degree of any polynomial has exponents. In the polynomial. So last year, when we did y equals mx plus b, well, the exponent there was technically 1. We didn't write it. So those were first degree functions. This, because we're using squared, means we're looking at second degree functions. Next year in grade 12, we're going to look at what third degree functions look like, what fourth and what fifth look like, because they take on different shapes. Okay. Now remember, a quadratic function, the highest exponent is 2. And the exponents, you can't have any fraction exponents or negative exponents. So, of these 6, which are quadratic, which are not? How about the first one? Yeah. Yeah, it's got x squared is the highest exponent that you see. It's got an x, it's got a number. How about the next one? No, because the highest exponent is 3. How about the next one? What looks suspicious?
2x.
2 to the x, right? We can't have a variable exponent. It has to be a number. So no. Because this has a variable exponent. How about this next one? Yep, that's good. Oh, the next one, you got to remember your exponents from grade 10. How do you write square root x as an exponent? Do you remember? Square root of x is the same as x to the... Do you remember? Remember we had a little 2 out there, square root? Does that help? Not x squared. X squared and square root x are very different. X to the 1/2. We did fractioning. I know, that was like a year ago, over a year ago. Don't expect you to remember that. So that means no. Because we can't have fraction exponents, and this one does. Yeah, because it's actually in vertex form. And if you were to multiply all this through, the highest exponent you'd see is x squared. So yeah, that's a guess. Okay. So how do we go from one form to the other? Well, going from vertex form, which this is, how do I always, like, usually with vertex form, you can recognize it by parentheses. Usually. Doesn't necessarily have to have parentheses. Okay? Because, say, something like this, like we did when we did this one. I gave you guys this one on the board. Technically, this is both forms. Because you could write it in vertex form by doing x minus 0. Or if you didn't have the parentheses, this is A, there's no B term. This is C. So technically both. Well, how do we convert? We just have to multiply it through and simplify it. So it looks like something x squared, something x number. So remember, x minus 3 all squared means x minus 3 times x minus 3. And there's still a minus 7 after. So I've got to multiply these two together, which means 4 multiplications. What do I get? X squared. Yeah, I'm going to split it up. You simplified it, that's fine. But you get x squared minus 3x plus 9. Don't forget, we still got a minus 7. Which becomes x squared minus 6x plus 2. And that's standard form because we've got x squared and x and a number. Okay. Well, you guys try this one. Put this one in standard form. Wait, no, it's not really in any form. It's not in vertex form. It's not in standard form, but I want you to put it in standard form, please. Well, the first thing I have to do, remember, f of x means the same as y, so you can write, it's okay to write f of x. So 4 multiplications, I'm going to get 12x plus 8 minus 3x squared minus 2x. And I also have a plus 2 after it. And then I got to rearrange everything so that the x squared is first, then the x's, then the constants or the numbers. So I got a minus 3x squared, just nothing to collect. The x's, I've got 12x and minus 2x, which becomes plus 10x. And then the numbers, 8 plus 2, which simplifies to 10. So that's standard form. Okay. So going from vertex form to standard form, you're just basically multiplying out and simplifying. It's pretty straightforward. The other way is not. And there's value in going the other way because, let me give you an example like this. What form is this in? Standard or vertex? Standard, okay? I want you, just by looking at this, tell me as many properties as you can. Can you tell me the vertex? No, because it's not in vertex form, which means if you can't tell me the vertex, you can't tell me the axis of symmetry. You can't tell me the maximum or minimum value. You could tell me if it's a maximum or minimum. Does this have a maximum or minimum? Does it open up or down? Opens down. So I mean, I can say it opens down. But I don't know why it equals, because I don't know the vertex. And if I don't know the vertex, I can't find the range. But there are a couple of other things I could find. What else? What's the same always? Domain. That I can write. There's one more thing I could find. Think of all the properties I asked you guys to find. Y-intercept. Because I make x 0. So I get negative 0 squared minus 7 times 0 plus 3, which just works out to 3. That's as far as I can go. Okay. I don't know how many x-intercepts there are because I don't know where the vertex is. All I know is that it opens down. I mean, is it up high and it opens down so there's 2? Is it down low so it opens down so there's none? I don't know. So I can't state. Okay. So we've got to come up with a method to get from making it look like this to making it look like this. Okay. But the first thing, and I'm going to actually stop here and pick it up on the next class, but I want you to see if you can find the pattern here. I'm going to give you a table. You don't have to copy that. Okay. X is 4. Y is 4. If X is 2, Y is 1. If X is negative 6, Y is 9. If X is negative 20, Y is 100. I'm just curious. It'd be hard to get. It's not an easy pattern to figure out. But think of all the things that you know how to do to find patterns. You know how to multiply, divide, add, subtract, square, square root. Any idea? Well, this is, I mean, like this one, if it's negative, it becomes positive and it gets bigger. But that kind of throws these ones out the window because this one's positive, yet it gets smaller. And this one's positive, but it stays the same. What's going on with that? Nothing? Take half of x. See if you can finish the pattern. Then square it. So the pattern is y is going to equal half of x and square it. Okay. So following that, we remember how to factor. Remember how to factor that? So x plus 2 times x plus 2, or x plus 2 squared. go fast. Call it when we can get something, a number or an expression, by multiplying something else by itself. Do you remember what we called that? Like, give me a number that you can get to by multiplying some other number times itself. 16, why? Give me another one. Perfect squares, okay? Algebraic expressions can be perfect squares too. Why are these perfect squares? Okay. Because it's the result of something times itself. Okay. How do I make a perfect square? What if I said this? What would you fill in as the number? This would be a perfect square. Think of the pattern I just gave you. 25. How'd you get that? Yeah, took half of 10 and squared it. And that actually works because it becomes x plus 5 times x plus 5, or x plus 5 squared. What would complete it? Plus or minus. Half of this is -7, squared is plus 49. And that works because it's x minus 7 times x minus 7, or x minus 7 all squared. What you guys just did here is you did the process of completing the square. Okay? How do you turn an algebraic expression into a perfect square when it's got an x squared and an x? You take half the number in front of the x and square it. We need to know how to do that in order to go from standard form to vertex form, which we'll talk about next time. So I'm going to leave it at that for now. And there is, I'm not assigning any.